Hey guys, it's Miss Berry again. I wanted to post another video for those of you that need a little pre-algebra review for 1 and 2 step equations. So many of you are doing these simple ones that we're doing right now in your head, and it's awesome that you have that mental math ability. But with these, as we get deeper into algebra, we're going to deal with some more complex equations, and it won't be necessarily as easy to do the math in your head for all of you. So I wanted to be sure and emphasize the processes that should be going on when you're solving these problems, kind of what your train of thought should be, and just make sure that you're really understanding how to work these problems so that when we get to more complicated ones, there's more going on, but it won't be near as stressful because you're going to know exactly how to solve them. So what we're going to be doing is, to start off with, when you have something simple like this, like x plus 5 equals 7, obviously you can look at that and go, oh, well, that's 2. We can look at that and know, well, 2 is what we could add to 5, that would equal 7. But what you really need to be thinking is, what is the opposite of adding 5 to x? Okay, so we're going to use those opposite operations. The opposite of adding is subtracting, and likewise, the opposite of subtracting will be adding. And then multiplication and division are opposites. They undo each other. So you always want to start with whatever is beside the variable, not attached to it, but whatever is being added or subtracted. When you think of doing this, when we're using opposite operations, you know, we've got our PEMDAS, and I'll just make a little note here. Mainly with the multiplying and dividing, adding, and subtracting, you kind of do those steps backwards when you're solving equations. Normally you would do multiplication or division first and then addition or subtraction. Of course, that would go left to right. But when we're solving equations, you kind of want to do that backwards. So we're going to start out by adding or subtracting, and we'll save multiplying and dividing for the end. So that being said, we're going to look at whatever is being done to our variable. In this case, what's being done is that 5 is being added to the variable. So the opposite of adding 5 would be to subtract 5. So what we want to do is subtract 5. And we want to do that to both sides. Think of your equation on either side of your equal sign. Think of that as being a scale, okay? If this was a scale, and on this side we have x plus 5, this side we have 7. Right now, as that sits there, that is a balanced equation. That is a balanced scale. If we go taking something from this side, such as that 5, we have to take 5 from the other side so that it stays balanced. If we do something to one side, we have to do it to the other. So that being said, I'm going to go ahead and draw a line here, and we're going to just kind of simplify things as we go. So a plus 5 and a negative 5 cancel each other out. That's the whole point of what we just did there. We got rid of what was attached to that variable. So I'm going to bring down what's left. So we would have x, bring down our equal sign. 7 minus 5, just perform that basic subtraction operation there, and we would get that x equals 2. Now if you wanted to check to make sure that you solved that correctly, all you would have to do is go back and plug it in. So to check, plug in x equals 2 into our original. So that means we would plug a 2 in where x was, which was right there. And so again, this equation should be balanced if it's done right. So this side of the equation is equal to 7. This side of the equation is also equal to 7. So we know that that's balanced. Okay, let's do another one. Let's say we have y minus 20 equals 45. Okay, so same process as what we did up here, only this time we're starting out with subtraction. So we need to undo that subtraction. What's the opposite of subtracting 20? It would be adding 20. So what you want to do is add 20. And again, we want to do that to both sides to keep that equation balanced. So That cancels that out. A negative 20 cancels out a positive 20. That's exactly what we're wanting to do, guys. Is just get rid of those things, and when we move them to the other side. So what's left on the left side of my equation is a y, and we have our equal sign. 45 plus 20. Of course, that would be 65. And again, if we wanted to check that, we would just plug in the value of 65 where our y is up here in our original equation. So if we were going to check it, we would just say that, well, 65 minus 20 should, and we hope, would equal 45. And of course, you're going to find out that that does in fact work, so that checks out. We're good with that. Okay, let's look at some multiplying and dividing. When you're doing, when you have equations that have multiplying or dividing, you're gonna have something attached to your variable, and that's where the multiplication and division part comes in. So something like this. Let's see here. Let's do 15. Okay. So, do not mess with this part first. We want to get rid of whatever's being added or subtracted to our variable first. Okay, the reason that is, like I said up here with our order of operations, we'll do these backwards. The multiply, divide, add, subtract of our PEMDAS, we're going to do those backwards. So we're going to subtract or add first, and then we'll multiply or divide. So the story that I usually tell some people, and this is kind of silly, but if it helps you remember, then it served its purpose. Think of your variable and whatever's next to it as scuba divers, okay? And they're watching sharks. Okay, so the variable the term that has the variable attached to it is kind of like it has a shark cage around it. So that scuba diver is pretty safe. It can't be attacked right away. This one does not have a variable, so we can attack that first. So when you look at that, you would just simply think, okay, which one has the cage? That one right there with the variable. So I'm going to attack the other one first. How do we attack that? How do we attack a negative 3? We do that by adding 3. And again, we do that to both sides of our equation. Negative 3 cancels with a positive 3. And then 15 plus 3 would be 18. Now I know right away you're thinking, well, x is obviously 9. But here's the process. Again, you got to know how to do these opposite operations. Before I do that, sorry. When it's right beside, you divide. So what I mean is when you've got a number immediately in front of a variable, you guys well know that that means multiplication. So how do we undo multiplication? That's multiplying by 2. Opposite of that would be dividing by 2. So that's why I did that. And again, we have to do that to both sides. 2 divided by 2 results in a 1. That's what we're wanting. So now we kind of have that invisible 1 there, which is the same as just x. 18 divided by 2 is 9. And then if we want to check that, if we're going to check it, that means we need to plug it in our original. So we would have 2. What used to be x, we're now going to say is 9. And then minus 3. That should equal 15. So 2 times 9 is 18. And 18 minus 3 is 15, so that does work out. Okay. Let's do another one. Let's do this one. 5 minus 4x equals I don't know if this is going to work out or not. We'll see what happens. Okay, so let's do that. we may get a fraction answer, and that's okay. So if we have this equation here, 5 minus 4x equals a negative 19. So this is where it kind of gets harder for some to start doing the mental math. So knowing this process is going to be very beneficial. All right. Now we didn't have our leading term be the one with the variable in this case, and that's okay. Don't let that confuse you. We're still going to deal with the term that does not have a variable first. Now what you don't see is that little invisible positive sign. So note that that is a positive 5. It's not negative. So how do we get rid of a positive 5? It's kind of like the same as how do we undo adding 5? Well, that's going to be to subtract. The opposite of a positive 5 would be a negative 5. So that's going to be our first step, to subtract 5 from both sides of our equation. So go to the other side of your equal sign, subtract 5. Now, this negative here, or this subtraction sign, is going to stay with that 4x. So when you go to simplify, make sure you bring the negative with the 4x. Now we have a negative 19 minus 5. Think of that as you owe 19 and you owe another 5. So how much do you owe all together? You can literally add those numbers and just keep it negative. So that would be a negative 24. Okay, now we're ready to do the multiplication or division. In this case, we have a number right next to our variable. That's a coefficient there. That number's called a coefficient. When it's right beside, you divide. So when you divide, you can't just divide by 4. You have to divide by the negative 4 as well. So make sure you do that to both sides. Negative 4 divided by negative 4. That cancels. Perfect. And then we end up with x equals negative 24 divided by negative 4. 24 divided by 4 is 6. Negative divided by negative is a positive. So our final answer would be x equals 6. And let's check that just for good measure. 5 minus 4, what used to be x, we're now going to use 6, equals, or should equal, a negative 19. Alright, so that means 5 minus 24 equals negative 19. And that does check out. So that is perfect. Okay. Let's look at one that's going to require multiplication, which means it's going to start out as a division type problem. So something like x over 7 plus, let's see here, 3 equals 10. Let's go with that. Okay. Again, we want to start by getting rid of whatever is next to our variable, whatever's attached to it through addition or subtraction. So we see that attached to our variable is, we're adding a 3 to it, so we want to get rid of that by subtracting 3 on both sides. And that gets rid of that. I'm going to bring this x divided by 7 down. 10 minus 3 would be 7. Okay. Now what we need to do is realize that this is, if we were going to verbalize what this says, it says x divided by 7. So what is the opposite of dividing by 7? Well, it's multiplying by 7. So what you can do is multiply both sides of your equation by 7. This is actually like a 7 over 1, but I just didn't write that in there, so I hope that didn't mess you guys up. But that will cancel each other out, leaving us with only x, and then over here we had 7 times 7, which is going to be 49. And let's check that. 49 divided by 7, I put 49 in where x was, so 49 divided by 7 plus 3 should equal 10. Well, we know that 49 divided by 7 is 7 because 7 squared is 49. So that would be 7 plus 3 does equal 10, so that checks out good. Alright, let's do a couple more. These are going to have some fractions, which I know you guys are super excited about. So let's say 1/3, I don't know, 1/3 x minus 4. Let's see, equals 4. Let's do that. So 1/3 x minus 4 equals 4. Okay, I want to start by getting rid of this 4 here, and note that think of that as a -4 or subtracting 4. It's the same difference there. So let's add 4 to both sides. That will cancel out. So that leaves us with 1/3 of x, or 1/3 times x if you want to say it that way, equals 4 plus 4, which is 8. Now, there's a couple of different ways you can think of this. You can think of this as being 1/3 being multiplied by x, in the sense that you need to divide by 1/3. And so that is one way we can do that. Now that looks really busy. It looks like there's a lot going on. But if you remember that when we divide with fractions, you actually need to multiply by the reciprocal. So that means you're going to flip the fraction and multiply. So I'm going to come over here for a second and clean this up a bit. Dividing by 1/3, it would be the same as multiplying by 3/1. So I'm going to do 3/1. This 8, and whatever I did to this side, I have to do this side. So again, I'm going to multiply by 3/1. Okay, so what happens is you can cancel out those numbers across your diagonals. That cancels out, and I would be left with x equals 8 times 3/1. Now don't forget that any whole number can be easily turned into a fraction by placing it over 1. And with multiplying fractions, we just go straight across. So that would end up being 24/1. So I'm just going to write 24 here. And that would be your final answer, so x equals 24. The other way that you could have looked at this problem, let me rewrite the original. Is like this. When we got, see, let me go ahead and catch up here so that we're ready for our dividing step. 1/3 x. Okay, so we're here. Now, up here I mentioned that this was like multiplying 1/3 by x. And so we divided by 3/1. The other way you can look at this, and you'll get the exact same results, the same thing, but it's to think of 1/3 times x as being this. 1/3 times x over 1. Now, if we think of it this way, like right here, that would be the same as, we multiply across, that would be the same as 1 times x, which is just x, 3 times 1, which is just 3. So 1/3 times x is the exact same thing as x over 3. Those are two equivalent expressions. So that's another way, if you like to think of it that way, you can very easily rewrite this equation right here, which is what I'm going to do now. And And I'm going to rewrite that as x over 3 equals 8. That now just became a much simpler problem. It resembles the division problem that we did just a moment ago. And we know that x divided by 3, to undo that, we need to multiply both sides of our equation by 3, which would give us x equals 24, which is identical to what we got here. So that's the same thing. It's just another way that is algebraically sound. That is a valid way to do that. You can always rewrite that. When you have a variable times a fraction, you can always combine those into one fraction. Okay. And that was a quick review of one-step equations. I'm going to do just one example of a two-step equation. It's probably one that you'll see the most. And we will do this. I'm going to tack on something else here. Okay, let's do that. All right, so let's look at this. We've got 3 times the quantity of x minus 4 plus 5 equals 21. Now, it seems like there's a lot going on there, but let's just do one step at a time here. The first thing we need to do is get rid of these parentheses. In this particular case, these parentheses are telling us that we need to distribute that 3. And I know that because that 3 is right next to that set of parentheses. So that's telling me to multiply. So what you're going to do is distribute that 3 to the x and also to the negative 4. It's very important that you consider that subtraction sign there as a negative with the 4. And you cannot separate those. So 3 times x would be 3x. 3 times a negative 4 would be negative 12. And then I'm going to rewrite the rest of my problem. Now we are ready to do what I will, I'll call it CLT. So if you guys hear me say that, that means combine like terms. So we're ready to do our CLT step. So that means we're going to combine the negative 12 and positive 5. I'm going to rewrite. If you owe 12 and you have 5, you still owe 7. So that would be a negative 7. So I'm going to write that as minus 7 equals 21. Our next, so now we're down to like a one-step or a two-step equation now. We're going to add 7 to both sides. Those will cancel, and we get 3x equals 28. The 3 and the x are being tied together through multiplication, so to undo that we have to divide. When it's right beside, you divide. So divide that 3 out of there. Divide by 3, and our final answer will be 28 over 3. That will not reduce, and that is okay. We're not always going to get a nice whole number that's positive and, you know, with no fractions or anything. So that is okay. We don't need to do anything else to that. And again, don't convert that to a mixed number. We want to leave that just like it is. That's totally fine. That's actually better. So there you go. Hopefully that helped a little bit. Oh, let me do one more actually. I do want to include one more. That's going to be very similar to this one. Let's do minus x. We'll go with that. Okay, so we've got negative 4 times the quantity of 5 minus x equals 32. Okay, same process as before. The negative 4 being bumped up right against those parentheses is telling me that I need to distribute that negative 4. So, negative 4 times positive 5 and negative 4 times negative x. The reason why I wanted to show you something like this was so that you can just see that you do need to distribute the negative with that 4, and note that that negative there goes with the x. It's very important that you don't leave those out. So negative 4 times a positive 5 is negative 20. Negative 4 times a negative x is going to become a positive 4x. And then we just write out the rest of our equation. Now we will go through and add 20. And we will get that 4x equals 52. Right beside, you divide, so we're going to divide that 4 out of there. And x will equal 13. There you go.